यूजिंग करते हुए, एप्लीकेशन करते हुए, हमें जब ये एक कंसेप्ट माइंड में आया रिसर्चर्स के, कि जैसे एक गाड़ी है, वो अपने डेस्टिनेशन पे जा रही है अपने सोर्स से निकलकर, और उसके बीच में जितने भी टोल टैक्सेस या जितने भी बीच में आप कह सकते हैं कि बैरियर्स आएंगे जहाँ पे उसकी आप चेकिंग होती है कि ये गाड़ी यहाँ से क्रॉस हुई है, तो क्यों ना एक ऐसा सिस्टम हो, क्योंकि जो टोल टैक्सेस हैं वो आपकी गाड़ी को सेंस कर सकते हैं जब गाड़ी सिर्फ उस पॉइंट से निकलेगी, और वो आपको एक इंफॉर्मेशन दे सकते हैं विद इन दी पार्ट्स। बट अगर आप उसको एक
Gaurav ji, if it is possible for you, then try to summarize it in English because many people are
श्योर सर,
joined from South India also.
श्योर सर,
So, so you can take the help of Hindi words, but
ऑफ कोर्स,
in between you use the English language.
श्योर सर. So the major thing is that if we want to notify that where is that car at that particular time, so we have to find that solution that it can give us the continuous information or continuous notification to get that what is the actual position of the car. So they change that RFID application into this IoT application, that you can get the data from anywhere at any time from any of the object or thing. So this is the basic thing that or basic history about the IoT, where from it starts. So the next thing is the applications where we can use them, that idea or that methodology. You can use them in the home automations, even in the wearables. You can We can create the wearables type of devices or wearable types of products, like if there is a patient in the hospital and the doctor wants the parameters of their blood pressure, what is the blood pressure of the patient, or what is the position of the patient, and if there what are the fluctuations in the ECG of the patient, so they can get that data through the IoT in their application or in their server. So the doctor is in the other place and the patient is in the hospital, even they can get the data from them. So we can make the variables also, variable devices for also, with the concept of IoT. In the industrial automation, I have already decided tell you that there are so many machines which are automatically uh, adapted or added with some IoT systems. They are coming in the marketing with already have the IoT systems, because they have their internal system who can detect that what is the life of the machine when it needs the services, so they can give you the indication before the time of service. So these are the methods or applications used in IoT, even industries. Even there are so many things. There are smart metering options also there, that you want to measure some uh, current voltages or some analog outputs from the sensors, and you want some data on the single server. So you can go for that using the IoT concept. Efficient water supply, smart traffic management system. There are so many things that we can do with the IoT, but it needs a proper, you can say that the proper flow chart, that how we will convert that concept or that idea into the practical application. So the basic concept behind the IoT is very little, but the application and the idea to create a new product using this technology, that is the vast thing. You can do many more things with this technology. So energy efficient products are there, smart parkings are there, smart street lightings, so many things you can do with the IoT. So the next thing is that how to start with IoT. So there are so many development boards are available in the market which can directly connect up with the internet, so that you can send your data or control your hardware with some commands from the server. So I will show you the basic development boards which are available in the market. So first are there. You can see here there is a MediaTek Linkit. So it is the Linkit development board which is created by the MediaTek, and on the other hand there is a Photon development board created by the Particles. There are Tesla created by the Texas Instrumentations. and Flora, created by the Adafruit. The most famous development boards are Raspberry Pi, Node MCU, ESP32. So these are famous because they are uh, used by some industries also, and even for the education purpose also. So these two boards are famous for their, uh, you can say that, to easy to use or easy to handle method. Due to their easy to use method, they are famous because it is very easy to work with them. So that is why they are famous in the market. So we will also go with these boards. One is a Raspberry Pi and another is the Node MCU. So we will go with them in our whole 4 sessions. So we will do some practicals also and how to use them, how to get started with them. So let's go started. So next thing is came to our knowledge is protocols. That what protocol we need to send that data from one device to another server or one device to another device even. So as I told you in the starting that it is a concept of network. So network means there are two devices which can communicate over the internet, or even there are some intermediates also there. Or you can say that the modems also are also there, so that the data from one device will arrive to that modem and then it will go for the next device. So these are the uh, you can say that the transformation objects, or you can say that these can help the transferring the data. So what protocols it needs to transfer the data? It is on your screen, that message queue telemetry transport. So this is the MQTT. So MQTT protocol is also known as the mosquito protocol. Basically, the concept behind is that it is a pub sub method. Pub sub means publish and subscribe method. Once a device when send their data, it is in the subscribe mode. Oh, sorry, publish mode. And when you get that data by the another device, it is the subscription mode. As you subscribe the YouTube channel, so you get all the notification from the respective channels. So same thing happens in that protocols. When a device publish their data on the server, so another device on the another place will fetch that data. So it this process is known as the publish and subscribe protocol. So MQTT is based on that protocol. And the another protocol is HTTP, hypertext transfer protocol. So it is basically depend on the get and post commands. The simple method where we can send the text formats over the internet. So these are the protocols which we can use to start making the projects of IoT. But even if you have your own server, you can design your own protocol also. I will tell you that some of the companies have already made their own protocols by using these two of protocols. Okay, so we will go further. So we will start with the Node MCU development boards, because there is a very little uh, theoretical knowledge required about the information and introduction. This was the all introduction about the IoT. If you want to start with some development board, so we need to shift with the uh, study of the development board. So we will start with Node MCU firstly, and then we will shift to the Raspberry Pi, because Raspberry Pi is by default programmed with Python language, and this Node MCU is programmed with some of the features, you can say that functional programming, or even you can say that the embedded C programming. So it is easy to start with Node MCU. So we will start it with firstly with the Node MCU, how to use them, how to make this any project on this board. So let me describe you the Node MCU. So you can say here, as I already marked them, this is the portion of Wi-Fi module. There is a Wi-Fi module known as ESP8266 is already embedded on this development board, which is very helpful, or which is the basic uh, you can say that the component of this development board, which help us to connect the internet. This board can be directly connect to the internet or a hotspot so that we can send the data from this development board to any server. So there are some input output pins also available on this. You can see here there are some digital pins and there is only single analog pin available on this board. Even there are some you can say that the serial communication pins are also available so that you can communicate it with any other devices via serially. So, okay, so we will discuss about it later that how serial communication works. So next thing is there is a 3.3 volt regulator. It means it is a very energy efficient development board because it works only on 3.3 volt and very consume very small amount of current, about 2 to 5 million amperes. So there is a USB to TTL converter IC because it helps us to convert the CMOS logics sent by the computer and it converts it into the TTL so that the controller of ESP8266 can get the hex file. So because we can directly code it by using the USB cable. So that is why this IC have an important role in this development board. So there is a reset button to reset the code and flash button also available there. So this is all about the pin description, basic pin description, or you can say that the blog descriptions about the Node MCU development board. So in the market, ESP8266 Wi-Fi module is individually also available. If you don't want to use this Node MCU development board, so in the market you can get the ESP8266 Wi-Fi module also. So because ESP8266 Wi-Fi module have only two GPIO pins on board, which module available in the market, it contains only two GPIO pins. So you have to interface that ESP8266 module with some external controller if you want to attach more of the sensors. So that is why we are choosing Node MCU so that we can easily interface more inputs and more can extract some more outputs from it. So let's go further. This is the pin diagram. You can see here some of the nomenclatures are available. As you can see here, this is the GPIO 16, GPIO 5, GPIO 4, GPIO 0 to some. So these are basically a GPIO pins available on this onboard. So as well as you can see on the other hand, there is the naming of these pins are available as D0, D1, D2, D3, and D4. So why there is a difference between GPIO nomenclatures and the standard nomenclatures? Because if you want to code this board in the Arduino IDE, so you have to use these GPIO nomenclatures. Okay, so if you want, even there are some another IDs that are specially designed for Node MCUs. So in them, in that IDs, you can directly use the D0, D1, D2 nomenclatures that are the standard. So if you want to code it with Arduino IDE, because it is very easy to start with, so that's why we will use this GPIO nomenclatures in our programming. Okay, so you can see here it is a 3.3 volt powered and you can even give input of 5 to 9 volt in V input. So if you have a power supply of 5 to 9 volts, you can connect it with this, or you can power it with USB power. You can make this powered up with the help of USB also. So you can see here there is MOSI, CS, MISO, SCK. These are the SPI communication pins to communicate serially with another device. So on the other hand, you can see the RX, TX pins. So there are three UART channels and one SPI channel. So it has many more things to do. So as per the requirement, we will use these features. So in further, how to start with ESP8266 development board. So firstly, if you want to code your Node MCU development board with embedded C language, or you can see that simply C language, so you need to put the firmware of C so that you can code your Node MCU development board with C language. If you want to code it with Python, so you can go with the Python configuration or file or firmware file for Python, so that you can code your node MCU with the help of Python language. So as per on your requirement or your working uh, environment, so you can go with the C or as well as Python also. So I will show you the practical. So let me take you the camera. You can see here, this is the node MCU development board. So you can see here, so there is the ESP8266 module. These are the GPIO pins available on this, or power supply pins. So I have connected it with the USB, so that we can start it with the putting the firmware on this node MCU board. So let me show you one another board. This is the Raspberry Pi board you can see here. So we will further move to this after completing the node MCU. It also have USB section, 4 USB ports, one Ethernet port, and even you get the 3.5 mm jack. You can connect directly your speakers here, and this is the HDMI cable. You can connect your screens, home TV screens, or even your computer screens with them. So you can see that there are lot more feature in the Raspberry Pi. So firstly, we will complete our node MCU. After that, we will go with no Raspberry Pi. I have another board. There is a ESP32 also available in the market. So let's get started with the putting the firmware into the node MCU. So now we need a firmware uploader. So I have this already downloaded in my PC.
All other participants, please mute your video and mute your microphone. Otherwise, I will immediately remove. Immediately, I will remove.
So this is the ESP8266 flasher.
Just
This
I
is
am
the
checking.
software.
1 minute, Gaurav.
Sure, 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 sure. No problem.
மேம் இதுல உங்கள என்னல வெளியில வந்தாவே அட்டெண்டன்ஸ் கிளாஸ்னு சொல்றாங்க மேம் எக்ஸைட்டா இருக்கக்கூடாது
Chaliye, please. Now I have
Sure,
removed you.
sure, sure, sure. Yes, sir. The next thing is, this is the ESP8266 flasher software, which will help us to flash the firmware in the node MCU development board. So firstly, I will open it. So you can see the interface. This is the interface. As I have connected my node MCU, so it is already showing me the COM4. It means my node MCU is connected on the COM4. So firstly, select this. After that, go to the config option and click on this setting button. So you can see the firmware.bin file is there. So if you get these files, you just have to go that on that particular file location to get this file, where you will locate it. So as I have selected this firmware file and return to the operation, after that click on flash. So it will take some time to upload the firmware. You can see here it is getting started. There will be a loading and it will take some time. Suppose if your device is not getting the AP-MAC and STA-MAC values on this software, it means there is some problem in node MCU. So you have to connect your USB again and try this process again. So let me checking it. So you can see now the uploading of firmware is started. So it will take just a few seconds to complete this process. You can see here the APMAC and STMAC is now showing to you on this screen. Let's just complete it. So as you can see, now it is done. Our firmware is uploaded perfectly. So now what we have to do, we have to close this, and now we can code our Node MCU development board with the helping of embedded C language. So how to start with embedded C if someone is new to this language? So we will start with some basic features. So now we have to go to the Arduino IDE. So Arduino IDE, it will help us to code our Node MCU development. So let me share you that how to add that uh, board files, because this is the ID for the Arduino specially. So we have to add the boards for the Node MCU, because Node MCU is not from Arduino. That is why we have to put some hardware files. So I will explain how to add that files. So you can see here your Arduino IDE is open. So I will click on the new button and open a new page. So you can see here, let me clarify you the basic features of Arduino IDE. Here there is a two functions available. You can say that the function blocks are available. First is the void setup, where you can put your code which you want to run once. Means if you have a that commands that you need at the initial point, and you want to declare them only for a once. You don't want to you can say that the compile them immediately or repeatedly in the loop. So void loop function or function block is there. So the code or the commands you want to run repeatedly, you have to put that all commands or code lines here. So this is the basic feature. Second thing, this is the verify button. Verify is like a compiling button as you compile your code in C. So same thing happens with this button in this Arduino IDE. Next is the upload button. So you can directly upload your code by clicking on this upload button. So next thing, what you have to know about this ID, you have to choose your board. As you can see that there is Arduino Nano is selected also, but you can see the all other options, Arduino Genuine, Geno, and so many options for Arduino is available here. So as you can see that because it is an Arduino IDE, so the boards of Arduino are already available in this. But Node MCU board, we have to add this Node MCU board in our board list. So how we will add it? You can go to the board managers and search for their ESP8266. So you can see here I have already installed these boards. So it is showing me the version to select because it is already updated. So I have already updated version is installed in my Arduino ID. So I don't have to install it. But if you using Arduino for the first time and Node MCU development for the first time, you have to install this boards in the Arduino ID. So you will need some internet for this also. The next thing, when you choose the board, as I will choose the Node MCU board here, you can see that there are so many boards available in this. So you can see the Node MCU. So we are using the 1.0 version. So we will go for the Node MCU 1.0. So as you have chosen your board, next thing we have to choose is COM port. COM port is the port or communication port uh, which is connected to your Node MCU development board. So you have to choose it wisely. So now how to started coding this Node MCU development board and how to use the GPIO pins. So let us get started with this. So as we have uploaded the firmware file into our Node MCU development board, so next step is to configure it. So how to configure it? Let me show you the documents for this. That how to configure your Node MCU. So you can see here, this is the document. These are the commands to initiate or configure your Node MCU. So first command is to attention the Node MCU. So we will put through serial monitor. So open the serial monitor. Here you can write your AT command. So firstly I will send AT. So as you can see there is no response. Even AT is not showing on this board. So we just have to reset our Node MCU development board. So you will enter the AT. So now you will get the response. Okay. After uploading the firmware, just reset your Node MCU development board once so that you can get the response. Okay. So next, the command is AT plus RST. This command is used to reset the Node MCU. Let me use this AT plus RST. You can see that you get the response okay, and it already makes it reset. So next command is the AT plus GMR. Why these commands are used for this Node MCU development? I will clear you with these commands. The AT plus GMR is used to get the version of the Node MCU. So AT plus GMR. So it gives you the ID. Next is the AT plus CW mode equals to 3. This command is used to make our Node MCU as both, means as a station or as the access points, means you can send or even receive the data on this Node MCU development board with help of this command AT plus CW mode equals to 3. So AT plus CW mode equals to 3. So this command will allow Node MCU to work as station and the access point both. Next is AT plus CW LAP. So AT plus CW LAP command will show you that how many hotspots or modem or internet connections are available around this Node MCU. So let me open my hotspot, mobile hotspot, so that it my can be located in this serial monitor windows. So my hotspot is in the active position. So I will put now AT plus CWLAP command. So when I enter this command, you will get the active internet connections. So you can see that there is a Redmi. This is my mobile hotspot name. So you can connect with this mobile hotspot by using the command AT plus CWJAP equals to or it needs the SSID and password also. So let me show you how to connect it. AT plus CWJAP equals to, in inverted commas you will write the exact name of the hotspot. It is Redmi. So as you can see that R is in capital and rest of the characters are small. So Redmi, after that comma, in another inverted commas you will put the uh, password for this. So 1 2 3 4 5 6 7 8. So this is my hotspot password. So when I enter this, if the credentials given in this command are exact and are right, so it will give you the OK. So now you can see that my hotspot is connected, or you can see that my development board is connected with the my hotspot, and I have get the notification also that one device is connected with my phone. So what is the next process now? Let me close this. Now the basic initialization commands are done in the Node MCU development board. So next thing what we have to do, we just have to add some Blink libraries in our C folder. Let's take me to the C folder. You can see here in program x86, if you have the 64 bit window, you will go to the program x86 files, and here you can see the Arduino folder here. Here is the library folder. You can see that the all libraries are in this folder. So if you want to uh, add some libraries which will helpful to create your project, so you will add that libraries here. So why we need this location and the libraries for this project? Because I will start with some third-party servers which are free to use. So let me take you the Blink app. Blink app is a server basically. So you can get the Blink app on your Play stores and even Apple iStores. Even it is available in both. So what we have to do? So this is the basic image of Blink app. Let me connect my phone also so that you can see it live. Pawan sir, hello.
You continue, sir.
Hello. Yes, sir. I will just connect it. If it will ask to join, so just help us to join.
Yes, Gaurav.
Yes, sir.
Please repeat again. Please repeat again what you said.
No, no, it is connected, sir. Thank you.
Oh, oh.
Okay, I just want to show you the Blink server, which is third-party server, and it is free or available to use to make projects. Okay, let me connect my phone. So my phone screen is sharing now. Is it visible? Okay. So this is the icon for the Blink app, which I have already opened. So let me firstly log out from this. Okay, so these are the basic interface. Firstly, when you open the Blink app, you will have to log in, or if you don't have your login ID, you have to create a new account. Okay, so it is very easy to create a new account by using your email ID. So when I go to the login, I will have to add my mail ID, and after that my password. So now it is logged in. So you can see here there is a already project created with the name of Unmode. So let me take you the procedure how to create project in Blink app. So this is a third party server. It is free to use. You can use their 2003 points, and if you want to use more, you have to pay them for points. So firstly, go to the new project, give it a name. Let me give it the name test. Okay, so I have put this name. After that, you have to choose your development board here. So we are using the node MCU, so we have to go for the node MCU. So it is with the alphabetical order LMN. So it will give, so you can see here there is a node MCU option is available. So my node MCU is based on Wi-Fi, so that is why there will the connection type will be the Wi-Fi here. So if you want some dark or light theme, you can change there. And now go to the create. So what is it is telling us that my authorization token is sending to this mail ID. Okay, so what is that authorization token? Authorization token means uh, a group of characters or a string. You can say that there is a string which helps you to send the data from one device to another device with secure manner. In a secure manner, we need some authentication codes. So why we need them? Because nobody can hack our data, so we need this uh, authorization token to communicate over the internet. So now what is the next thing? Suppose you want to control any GPIO pin on the Node MCU development board, so you have to use some widgets. So I will click on the plus icon. So after clicking the plus icon, you can see the widget boxes available here. You can choose your button, style button, sliders, vertical sliders. There are so many options available. So we do not have to write codes to make that buttons or make that graphs. So it is easily available here. You just have to put and drag into your application window. So I will use the button to control the Node MCU GPIO pin. So you can see here on the screen that the button is chosen. So when I click on this button, it will show me the properties. So what we have to change here, you can give any name to this button. So I will not provide any name. So there is a pin option. Suppose Node MCU development board have onboard LED connected with the D4 pin internally. So I will choose pin number D4. You can see here D4. Okay. So as I have chose the D4 pin, then press OK. So you can see here this is the D4 pin. So logic will go like a 0 to 1. Means if you single time press your push button, so it will gives you the one logic, and then again if you push them, it will give you the zero logic. So it means the value sent by the button on pressing time, it will send you the 0 and 1. so that your LED can glow. So there is another option that you want to make your button as a push button or a switch. Push button means until you will press the button, the one logic will go to the uh, your server or go to the hardware, and if you release that button, the zero logic will go. So I don't need push button application, I need switch application. So I will turn it to the switch. Now I will come back to the main home screen. You can see there there is a triangle button you can see on the screen. It is the play button. Means when the code written in the Arduino IDE will be put it into the node MCU. So after that, you have to click on this play button so that you can control your LED on board with the help of this button available on the Blink app. So it is connected via internet. There is a no communication serially or any other type of connection between the Node MCU and the Blink app in my mobile. So it will send the command over the internet. Okay. So let me return to the PPT or Arduino IDE that how to write a code for Blink app. So my screen is visible now. Okay. So how to write the code for this? You can go to the file menu and go to the examples, because I have already added some Blink libraries. So there is a option with Blink because my boards are Wi-Fi. So I will go to the boards Wi-Fi, and you can see that there is an option of ESP8266 standalone. So there is an example code available in this file. So when I will click on this, I will get that example code. So it is very easy to start with. After that, I will tell you that how we can add our code of lines in this code so that we can make the project according to our personal requirements. So firstly, what we have to note down, you can see here the ESP8266 Wi-Fi.h header file is included, and another header file is blink simple ESP8266.h header file is included in this code. This is must for this IoT communication. So now next thing is the another thing is there is an array which is named with auth, that is for the authentication code. So what we have to do, we have to write our authentication code here. Okay. So the next thing, the SSID and password. So SSID with which the development board will connect. So we have to write here my hotspot name and the password here. After that, you can see here the serial begin 9600. It means serial.begin means there is a it is a predefined function with the name of serial.begin, and 9600 is the baud rate. Baud rate means if we talk about the serial communication, so every data uh, is sending by the device is in the serial mode or even the parallel mode, but parallel mode is very complicated because there are so many wires. So we use the serial mode to transmit the data or receive the data. So serial.begin command is to initiate the serial communication with 9600 baud rates. Baud rate means bits per second. Simply 9600 bits per second. This is the speed of the serial communication. After that, blink.begin. So it is also a predefined function. So they are predefined in this library. You can see here, these are predefined in these libraries. So we just have to call them. So we call this function blink.begin and provide the authentication token, SSID and password here. Okay. So we use these variables in this function as argument. So next thing is while loop. So void loop, as I told you, that that uh, codes and the line of commands which I want to run repeatedly, I will put them into the loop, and which I run once, so that line goes to the setup function block. So these commands will run only once. After that, it will enter to the void loop and runs this command, this function repeatedly. Okay, so this is the all what we have to change in this code to start or to blink the LED. So what we have to do now, we have to put our authorization token. Let me add this. Okay, so I have sent my authorization token to my mail so that I can get directly into my PC. Okay, so let me take you my Gmail. So your authorization token will go to your mail, so you can directly fetch your authorization token from the mail ID. So this is my authorization token. I will just simply copy it and put it into the here. So between the inverted commas. So like this, you have to put your authorization token. The next is our SSID name. So this is the Academy and our password 1 2 3 4 5 6 7. So this is our password which is collected. So these changes we have to make in this code. After that, as I told you, that go to the boards, select Node MCU board, COM port 4, and Arduino as ISP program. Okay, fine. So now we have to just click on this upload button. It will take some time to compile, and after that, it will go for the upload session. So when upload will start, there will be the blinking of LED on this Node MCU development board. It is taking some time to compile because you can see that the number of code lines are not maximum, but because we have used the libraries, so the libraries have a very large number of code lines. So when we include them, so compiler goes to that libraries and compile them, so it takes some time. So in main window, you can see only a few lines of code, but in the background, the libraries we have used, so they have the large number of code lines. So that's why it takes some time to compile. So you can see the blinking of LED because code is uploading now. So it is uploaded. Okay, it is uploading. I will share the details about this PPT and the whole procedure we are applying on this Node MC development board. So I will share the all details at the end of the session so that you can make some practicals at your home or at your so it is shown by the Arduino ID that uploading is done. So the next step is we just have to go to the Blink app and check our output. So firstly, showing me would be Blink app. Let me share my phone screen. So my phone screen is sharing now. So you can see here what we have to do. We just have to uh, click on this play button, and after that you can see here the some diagram of the node MC or development board here. So what we have to do, we just have to click on this and you will get the notification that your device is online. It means the authorization token entered by us is exact and correctly, and our device is also connected with the internet. So this is the information which we have to verify before testing your node MC development board. So as you can see that when I will click on this, so my button will show you the on state and off state. So because my LED is connected with the uh, ground detection, it means when I will click on this, when it shows you the on option, so my LED on the development board will get off, and when I press it off, my node MC development board will show you the blinking of LED. So it means LED is active. So as you can see that it is it visible when I press the blink button.
Yes, yes, it is visual. It is visual, Gaurav.
So when I click on this button, my LED will be active, and when I click it again, so it will get off. So if you want to change this, that when it shows the on, so there would be the LED in the active mode. So what we have to do, just stop it, click it on the button option. We have to just change there. We have to enter the 1 on the off position and 0 on the on position. We just have to change this. After that, when I will play this, now when I press the button and it show you the on notification, and as you can see your LED is also blind. So with some basic changes you can just control your hardware. So if you want to control from your at on place, you just have to download your uh, blink app, and we just have to change our authorization token in this, and you can just control this node MC device from your on place. So this is the first experiment, which is a very basic, but need to know how to start with this fundamentals, how to start with this node MC development board. So these all are the procedures which I have shared you in this session. So the next thing I will share you that how to use, because this is the uh, simple or you can see that the simply a controlling output example. So if you want to get some sensor data, that sensor will send you the information, or your sensor will interface with this node MCU GPIO pin, and he will give you the detection that either the sensor is giving high output or low output, and you want that detection on your blink app. So you just have to change your uh, widgets here, and you just have to write one or two pieces of code of line so that it can work properly. So let me move you to the next example, that how to get the input. Okay. So next thing.
So Gaurav, I hope you will finish your session by 4:50.
Sir, 4:15. Yeah, I will
Okay.
complete it with 4:15. Okay. Just
Okay.
just last example for today's session. Okay, sir.
Okay. Okay.
So I will show you the next example to get the analog sensor data, because the sensors available in the markets are of three types. First is the digital sensor, which gives you only high or low logic, and the another is the analog sensors, which gives you the voltage difference between, or you can say that the voltage between 0 to 5, or the current sensors also are also there, which comes into the range of 4 to 20 milliamps. And the third type of sensors are the communication protocol based sensors. So some sensors come with the communication protocols. It means they capture their analog value and send it using the UART channel, or by using the SPI channel. So these are three types of sensors which are available in the market. So what we have to do, we will go for the analog sensor. So at this time, I don't have the analog sensor, but I will show you the voltage. When I put 5 volt on the analog input, so what will be the output of analog converter? I will show you the values on the blink app. When I put 3.3 volt, what will be the value of 3.3 volt in reference to the ADC conversion? So I will show you the all values by changing these voltages. So what we have to change in this code is just thing. You can see here, we just have to write this line in our you can say that the code. So this is the I take variable which named as a var, and I have read the analog pin. You can see that the temp pin is the analog pin, which is cleared on this. Let me show you. Okay, so this is the temp pin. Okay, so for this sensor interfacing, we just need to know that what is the GPIO pin of the S0. Let me take you to the PPT. What is the GPIO pin? So you can see that there is a ADC0. Let me show you this clearly. So it will be named as ADC0, means you can use the A0 directly. Okay. So what we have to do, we have to go to our code which I have made last time. Okay. So now what we have to do, what we just have to declare.
Maharshi Trivedi, Devyan Bhattacharya, and Dharmachari ji, it is visible at our end. The screen is visible at our end. I don't know why there is problem at your end, because he is presenting from, I think, Kanpur, and I am here in Lucknow. So it is clear at my end. They are saying screen is not visual, but please continue. I think it is
Okay.
the network problem at their end.
Okay. Noted. Okay. Ask them that now it is visible or not. Okay.
Now visual.
So
Now he's saying visual.
okay. Sure.
Yes,
So
in the
what?
presentation screen, then it will go into the full mode. Yes, somebody is suggesting that's correct.
Yes.
Yes,
Okay.
Gaurav, please continue.
Okay, sir. Okay. So what we have to do next, that we just have to, as we can use directly digital pin from the Blink app, because it is already defined in the Blink simple ESP266.h for header files. Because everything is predefined in this library, so you don't need to add that either we want to make our GPIO pin as an input or output. You can just control them by using Blink app. For analog purpose, for analog sensor purpose, what we have to do, we just have to do read the analog pin. So how to read them? Suppose I take a variable here, suppose int a, and what will uh, what will be the value of the analog sensor? It will stored into the a variable. Okay, so let me go write the command for this. This is the analog read. So you have to write the analog read command here like that, and after that a0 here. So this is the analog read command. A0 means it will read the A0 analog values and convert them into the digital values. So let me clear you that what is the ADC conversion. Suppose there are sensors and they give us output in the voltage form. So they give us voltage in from the changes from the range of 0 to 5 volt. So what we have to do, there is a ADC conversion. The 0 to 5 volt, when converted by the ADC, it gives us a value of 0 to 1023. Means there is a digital value 0 to 1023. So how the ADC convert this analog voltage into the digital value? Because of their how the number of uh, bits, basically what is the number of bits of the ADC, how much it can convert from analog to digital. So because our node MCU development board contains 10-bit ADC, so 10-bit ADC means 2 raised to power 10, which is equals to the 1024. So 10-bit ADC means 0 to 5 volt will convert it, and it will show us 0 to 1023 in the digital form. So we can get that values by putting this analog read command. So what will be the voltage or value sensed by A0 pin will stored into the A variable, and this A variable, the value of this A variable will send to the Blink app. So what will be the next command to send this? The next command is virtual pin. So the virtual pin concept come here. As you can see that there is a simple command blink dot virtual, right? Okay, so v1 comma, there should be the a. So let me show you this same thing. So next thing, we have to send this value stored in a in blink app. So blink dot virtual, right? Firstly, on which channel we have to write? We have to write on v1, suppose v1 comma, and what value we have to send? The value from a. Okay, so this line we have to add. So after adding this line, you can get your analog value or analog value of any sensor from your development board to the Blink app. So you can get that. So after that, what we have to do? We have to upload this code. So as upload is uh, code is uploading in the NodeMCU development. So let me take you to the Blink app, that what widget we need now to check the values from the analog sensor. Just single two line code will gives you the different output. So my mobile phone is screen is visible now. So I will go to the Blink app. Now what we have to add, go to the add button plus, and now go to the value display. Okay. So you can see that there is a small box. Let me configure it. So click on this. You can give them analog val. You can give them any name. So there should be the virtual pin because we have used virtual pin. So what we have to use virtual V1 pin here. So what value you want to show on this Blink app, you just have to add here. Here it is by default on 0 to 1023, but if you want to see only 0 to 100 values, so you can just change here 1023 on the place of 1023. You just have to put your required value. So I will not change it, and the notification should be the in push mode, means in what interval of time you want to read or you want to get that analog values in Blink app. So I have put it into the push mode. Push mode means without any delay, just push that value on the Blink server by the NodeMCU. But you can change it from push to 1 second, 2 seconds. So with that particular time interval, or after that particular time interval, you will get the updation of analog sensor value sent by the NodeMCU. But I will set it into the push mode. Okay. So this is all what we have to change in our Blink app. So now I will return to the my laptop screen, or let me firstly upload.
Gaurav, you have three more sessions, so you can continue. If it is not much disconnected, then you can continue it in next session.
Sure, sir.
But
Sure,
if
sure.
it is necessary, then you can continue for 4 or 5 minutes.
Oh, yeah, sure, sir. It is just almost completing.
Yes. So wind up in 1-2 minutes.
Sure, sir. Sure.
Okay.
It will be completed now. It's just taking time to uploading. Finally, it is uploading. Just give me. So my phone screen is visible. I will put it into this play mode. Okay, it is showing some error to upload. Okay, sir. We will continue it in the next session, and we will starting with this to show the analog value.
There is one question, Gaurav.
Sure,
If
sir.
you can answer, or in next
Sure,
session
sir.
maybe. He is Dharmachari. Dharmachari is asking, in code
Okay.
written for analog sensor, Blink
Okay.
simple SP8266
Okay.
H.H library is not shown as active.
Okay.
Even though code doesn't give any error, could you clarify my doubt?
Okay. They are
So could you
telling
clarify
that.
this doubt?
Okay. They
Some
are telling
library
that.
of Blink he is not
Yes, yes.
shown as active, he's saying.
Okay.
But
So,
although he's saying that code doesn't give any error.
yeah, of course, because it is available in my library folder in the C. Okay, that is why it is not showing. Because if I put some library in my code, and if it is not present in my library folder in C, so it will definitely show me the error. So they are asking about the, it is not looks like in orange color as it should be, because it why it is not looks like in uh, orange color, because these are the user defined libraries. These are not defined by the Arduino ID. That is why it is not showing in the orange color. Okay, so these are the user defined libraries, so which are defined by the users, not by the Arduino community. So that is why they are looks different, uh, yeah, rather than the ESP8266 Wi-Fi.h header file. So it doesn't mean it is not present. It is present in my C file. That is why my code is running. Otherwise, it will show some errors.
So hope Dharmachari ji, you have got the point. Okay, he have got the point. So thank you,
Yeah.
Gaurav, for giving the live demonstration of these
Thank,
things. So people who are new in this field,
thank you so much. Thank you
they
so much.
they will get interest for doing some research, good research, and some
Of
practical
course.
work in this field. So
Sure,
we
sir.
will meet again since I have allotted you. I already know that you are doing some practical demonstration
Yes,
and
sir.
real application in the this field. So I have that's why I have allotted you 3 more slots. So
Sure.
definitely you will clarify more and more doubts and practical application.
Sure,
So thank you. Now you
thank
can
you so
leave,
much. Sure, sir.
Gaurav.
Sure, sir.
And
Sure.
one more thing,
Thank you.
many people are asking for your PPT. If you are comfortable, then you can give it to
Sure,
me. I
sure.
will
I
share.
will, of course, sir. I will share you the all details for today's session. Okay, sir. You can share them. It is open. Okay,
Okay. So now you
okay,
can
sir.
leave, Gaurav.
Okay, sir. Thank you so much.
Okay,
Thank you so
welcome.
much.
So, dear participants, now today's session is over. So, thanks for your participation and uh, your patience. Hope you have got informative knowledge from the academicians as well as from the industry persons. Uh, we have mixed the designed the program in such a way so that experienced people, young people, and from the industry people, you get a wide spectrum of knowledge and uh, uh, real experience, real field experience. So one thing I want to know from your side, that some people, one session is mandatory in this faculty development program for human values that has been fixed to 2nd of November, and one more thing, on 2nd November the session will start by 1:30 p.m. Because the human value session will be conducted by 4:30 to 6. One more request from Delhi is coming to my to me, that they want to conduct some meditation session. So if you if most of you are interested, then we can set for 30 or 45 minutes, 1 or 2 days for the meditation session. But that will be not counted in this. Just I will create the link and they will give the it is free of cost, and they are highly interested. In fact, they have mailed me well before uh, time, but I couldn't recall them at the time when I was sending the invitation. So, but if you people want, then we will create 1 or 2 days meditation session also after 4 to 4:30 or 4 to 4:45. You can give your suggestion on my mail, etc., that whether we should do it or not. Otherwise, this schedule is already given to your mail ID, and I will give the link of the session just before 10 to 15 minutes of starting the session. So thank you. Uh, now you can leave the session. After 5 minutes, I will terminate this.